Good morning, everyone. Thank you for joining us for the Smart Battery Management webinar. My name is Eileen Wegmeyer. I am a marketing specialist at Flow-Rite, and it is my pleasure to be a part of the team on the call today. I'd like to bring to your attention a few items before we get started. In your control bar, there's a tab labeled Handouts. We have placed a few PDF files there for you to download as resources for the topic of discussion today. Also, I'd like to let you know that after the presentation, we'll be emailing a survey. We would really appreciate your feedback. So if you could answer that, that would be really awesome. So without further ado, I'm going to turn it over to Hannah McCarthy, our Central Regional Sales OEM rep, to begin the presentation. Hannah, take it away.
Hey everyone, my name is Hannah McCarthy. I'm the Central Regional and OEM Sales Manager at Flow-Rite Controls. And I would like to thank everyone for joining us today for our Smart Battery Management webinar. Today, I will be joined by our Principal Engineer, Hank Bana, and our IoT Manager, Craig Kelm. Our presentation today should take about 30 minutes with a question and answer portion at the end. Our main goal today within these next 30 minutes is to demonstrate how our sensors, paired with a single point watering system, can provide a complete solution for battery maintenance for any application or customer. On our agenda today, we'll have a brief introduction to Flow-Rite, an introduction to the rest of our sales team, and then we'll move into Flow-Rite's suite of sensors with a focus on advanced battery Steward. Before we begin, I would just like to thank everyone for attending today, and a special thank you to everyone that attended our last webinar. As mentioned before, there will be a question and answer portion at the end of this presentation. Questions can be submitted in the panel to the right of your screen. With that being said, let's start this presentation with some quick facts about Flow-Rite. Flow-Rite is a 100% vertically integrated company, including doing our own captive injection molding. So what does that mean? This means that from the design of our products to manufacturing, assembling, testing, and packaging and shipping, we have complete control. All of our products are produced in our Byron Center, Michigan facility, which, if you're familiar with Grand Rapids, Michigan, we're located right outside of Grand Rapids. And this is also our headquarters, where most of our team, with the exception of a couple sales managers, is located right there at our headquarter offices. Flow-Rite is also 100% up to date on our ISO certifications. We as an organization are very proud to be able to share this information with you and your customers and everybody that uses our products year after year. Our team works very hard to provide the best possible service and sales team, but also the best quality product. This is something that we really wouldn't be able to do if we didn't have complete control over our products from the start of this process all the way to the end. As we move through the presentation, we don't really expect you to remember every detail discussed, and that's why I wanted to introduce you to the rest of our sales team. We have Ashley Tobin, who is our Eastern Regional and OEM Sales Manager, Kyle McKee, who is our Western Regional and OEM Sales Manager, and Rob McKnight, our Southern Regional and OEM Sales Manager. As questions come up in the next couple of days or weeks, or if you would like us to provide more detail on a specific topic discussed today, please reach out and we would be happy to help. Moving into our Eagle Eye line, many of you that have worked with Flow-Rite in the past probably best know our Eagle Eye sensor as our drill-in level sensor. However, we really have three products that make up this complete Eagle Eye product line. We have our simple sensor, our drill-in sensor, and our in-valve level sensor. Our simple sensor and our drill-in sensor, as the name suggests, require a user to drill into the top of the battery in order to install. The simple light, also as the name suggests, is really just that. It's simple. There's a light located on the top of the probe that will be green if the electrolyte level is okay, and that light will be off if the battery needs to be watered. Our drill-in level sensor operates pretty similarly, but rather gets a little bit more technical with a green and a red light. The green light signifies that the electrolyte level is good in the battery, and the red light means that the battery needs water. This light is offered in both a remote and a local option, with the light being located directly on top of the probe. Just as a quick reminder, at Flow-Rite, we always recommend putting one light per battery system somewhere in the middle of that battery. Generally, this is where the electrolyte will disappear from first, so it's a good spot to put the light. Our third option is our in-valve level sensor. Unlike our other two lights, the in-valve level sensor does not require a user to drill into the top of the battery to install. What we did is take out the optical indicator, which is normally in the spot where we inserted a level sensor probe. This fits into the battery like any of our standard valves do. This light is powered by a connection to the positive and negative post, which means time does not have to really be spent figuring out the correct amount of cells needed to power that light, or the correct amount of voltage needed to power that light. It also operates on a wide voltage range from 12 volts all the way up to 48 volts. Also, because the probe is in the valve, it is already cut to the appropriate length of the cell depth. So adjusting it or trimming it in field to match that cell depth is no longer needed, which can help cut down on installation time. Our in-valve level sensor features a bright LED green and red remote light, which can be adjusted to wherever is most visible to the operator. As I mentioned earlier, Hank Bana, our principal engineer, is also joining me on this presentation today. And since he is the brains behind this product and our entire battery management line, I want to welcome him to kind of explain a little bit more about the product history and what prompted our team to design this. So Hank, would you mind sharing some information on our in-valve level sensors?
Yeah, sure. My pleasure, Hannah. Hi, everybody. This is Hank Bana. I am the principal engineer here at Flow-Rite. So typical standard has been drill-in probes in the industrial battery world. And as Hannah mentioned, you're trying to figure out a couple of cells over where to put your power to make sure you have the appropriate level of energy to run that probe. But, we also service deep cycle and commercial battery customers. And deep cycle commercially battery customers that are running pallet jacks or scissor lifts. And I learned yesterday they're not scissors lifts. Little private joke. We went through our Flow-Rite rehearsal yesterday and I kept saying scissors lifts. Okay, show of hands. How many of you folks today knew that they were called scissor lifts? 1, 2. Okay, most of you I see knew that they were called scissor lifts. I did not. So they're not scissors lifts, right? Also, golf cars are not called golf carts. I tripped over that one too. The golf car manufacturers don't like when you call their golf cars golf carts. But golf cars, floor scrubbers, and they actually call floor scrubbers floor scrubbers. Anyway, these customers, they wanted to be able to measure electrolyte level in their applications as well. And because they don't have gobs and gobs of stored energy that we would have in an industrial battery, they were very keen with their specific requirements. One, okay, they don't want to drill into the top of their battery. Two, they want to power it from the entire battery set. You don't want to preferentially degrade or draw upon one deep cycle or one commercial battery when you have a number of them in a setup, right? And then finally, they needed to have low current demand. Unlike industrial batteries that have gobs and gobs of stored energy, the industrial applications are different, right? The deep cycle applications, the commercial applications, much smaller batteries running equipment. So we took all of these requirements, essentially put them in a bag, shook them for about 7 months, and then from inception to delivery to customers in 7 months' time, we offered this valve probe-based device, the Eagle Eye level sensor. And our deep cycle customers, our commercial customers, great commercial response. And that's part of being a vertically integrated company is you can make these things happen rapidly. Well, it was out in the market for a while, and all of a sudden we're getting some signal back from our industrial customers saying, wait a minute, we can have a probe that we can put into the battery without drilling in the top of the battery? And the answer, of course, from us is yes. So we now have this battery line. You can see the different valve lengths. We've sort of expanded it to actually cover not only deep cycle and commercial batteries, but all of our applications for SPW for industrial batteries as well.
Great, thank you, Hank, so much for sharing a little bit background on our in-build level sensor. Now that we've discussed our sensor technology, we're going to move into more of our battery management systems, Battery Steward and Advanced Battery Steward. Both of these offer a more connected solution for maintaining your battery fleet. Battery Steward is a cloud-based monitoring system that focuses on keeping a list of completed maintenance tasks in one centralized platform. Users also have the ability to create and keep a schedule for day-to-day tasks with reminders sent to your phone when tasks are due or if a task is overdue. It will continually send reminders until that task is marked complete. Data is entered manually through the use of the corresponding application and web portal. Battery Steward was really our first step into the IoT space and was released about 5 years ago. Our next step, or next generation in this space, is Advanced Battery Steward. We took those same ideas and principles that Battery Steward was founded on and expanded. Through the use of a battery monitor, Advanced Battery Steward tracks key maintenance events, but also focuses on monitoring battery health. Information is communicated to the application and web portal through the use of a gateway, which can be powered via an internet connection or cellular dongle. This means that once that tracker is installed and the gateway is plugged in, users don't have to do anything further to collect that data. As long as the tracker is pairing with the gateway, it will be uploaded into the cloud and put into the app in the web portal. So data can really be accessed anywhere. I'm going to ask Hank to come back and explain a little bit further what information that tracker is actually capturing.
Hi everyone, yeah, Hank again. So I think of our tracker, we talk about a battery monitor for battery health. It's very similar to a health monitor you might wear on your wrist, right? It's a connected device. We talk about connected devices in a bit. Craig will cover how that works with our device, but essentially it gathers information from the battery from a number of different sources. You can see the sensor array. We'll talk about that momentarily. And that information is accumulated on our tracker and then sent up into the cloud. And again, you can see this picture, the multiple different links to satisfy the multiple different industrial applications we might serve. First thing I want to talk about is fluid level. Fluid level is kind of the cornerstone of battery maintenance, right? We recognize that in an industrial battery, in any kind of flooded lead acid battery, the electrolyte in the battery is very energetic. That is where the energy, the stored energy, the potential energy resides in the fluid. And as you're charging and discharging the battery, as you're pulling energy out of the battery, you're actually transferring ions, sulfate, sulfur trioxide. These things leave solution and adhere themselves to the battery plates. When they do this, when they give up their energy, right, they come out of solution and they actually drop the fluid level in the battery. When you charge a battery, you drive those sulfate ions back into solution and the fluid level again rises in the battery. This is that sort of living and breathing action that happens in a flooded lead acid battery. But also during charge, right, you could actually generate gas, right? We know when you walk into a battery room and batteries are under charge, you smell that kind of rotten egg smell, right? That's hydrogen sulfide. There's not much of that, but our noses are very sensitive to it. But what you don't smell is the hydrogen gas and the oxygen gas being generated during charge, and especially during equalization. You know, theoretically speaking, you know, Michael Faraday, Faraday's law, right? You can generate anywhere between 300 and 600 milliliters of gas per cell per amp hour, and that adds up. So as these batteries are liberating hydrogen and oxygen gas, you have to replenish that with water. And that's why we have watering systems. And monitoring the fluid level is a key important product in determining what the level and when you have to water. Next step, next slide, would be energy in and out. Again, this idea of energy migrating from the electrolyte to the plates back and forth, that's current being demanded by your equipment, whether it be a scissor lift, whether it be a fork truck, whether it be a golf car, right? And the charging application, putting energy back into the battery. We want to watch and make sure we see current coming and going. That tells us the battery is being used, but also we keep track of it. We aggregate how much time it's on charge, how much time it's being run, and how many amp hours are coming and going to make sure your battery is being fully utilized. Next slide is voltage. Now, again, I talk about this idea of the fluid level coming and going, rising and lowering, but we also recognize that to properly maintain a battery, you always want to water it after you've charged the battery. For example, if you deplete the battery, you've run your fork truck, your battery low, the fluid level has dropped, and the battery monitor is saying fluid level low, you see a red light blinking, an inexperienced operator may go and water that battery. Then what happens is the fork truck goes and gets charged. Those ions come out of the plates back into the solution rises, and all of a sudden you got a boil over. You've got battery acid everywhere. We want to help the customers recognize when it is safe to charge, when it is okay to charge, and when it's okay to water. Okay to charge is from our voltage output. Okay to water is when our voltage is high and our fluid level is low. We also look at half voltage, recognizing that as cells degrade, as batteries degrade, they may lose some of their open cell voltage. We want to help customers recognize if there's an issue with a cell or a battery in the battery set or the cell in the industrial battery, that they can respond to it. So that's a customer setup voltage threshold for half voltage. So a customer can determine when they want to be notified of a half voltage imbalance. Next slide is watering events. So we keep track of and timestamp every watering event that a customer does on their battery. And that way you can be assured that your batteries are being maintained on an ongoing basis. And also it can be utilized as a training aid. The example I gave earlier, where an employee perhaps watered the battery before charging, and then we had a boil over, the employee may come and say, I don't know what happened. It's a big mess. Things aren't working properly. You can go back in and look at the history of charge in and out, half voltage and full voltage, fluid level, and say, golly, I see you had a watering event prior to having a charging event. With that information, armed with that information, you can then help train your employees to successfully manage and maintain your batteries. A couple other things we look at temperature. Right now, this is not temperature that you would decide what jacket to wear outside, right? This is a 5 degrees Celsius temperature change in the ambient temperature in the area of your battery. Our monitor is sitting on top of the battery. It's feeling what the battery feels, right? What you're looking for, not so much is great excursions, but just to make sure I see temperature changes over time as a customer. That's important, recognizing your battery is being utilized. If you don't see these temperature excursions, you might ask yourself, is my battery being utilized? If it's lying there like a dead fish and there's no temperature change, you might go back and look at, okay, now am I seeing current coming and going? Am I seeing voltage excursions? Maybe this piece of equipment I have is not being properly utilized. Helping to make a determination in terms of your fleet size and fleet utilization. I think the last slide I have here is battery impact. Yes, so we have an accelerometer. Much like you do on your Fitbit on your arm, we have a battery accelerometer in our tracker. And it's looking to make sure batteries are running in an expected manner, right? Customer sets up the G load of interest. For example, if I have a sit-down fork truck that's coming and going with pallets in and out of a van, loading a truck, I might see some reasonable G loads in a fork truck like that and would expect them. Conversely, I might have a reach truck or a pallet jack on the floor. I would not expect a pallet jack or a reach truck or an order picker on the floor to be seeing large excursions in impact. Well, a customer can set these impact levels up as thresholds and then be alerted if fork trucks or batteries themselves are being mistreated, being treated in a way that is outside of your expectations. Again, that helps you reinforce proper standards in the facility, validating equipment's being utilized properly, and batteries aren't being put at risk. I think that's all I got here, Hannah. Yes.
Well, thank you so much, Hank, for explaining what our tracker is capturing.
My pleasure.
Everybody clap for Hank now. As everything becomes a little bit more and more digital in the world, when creating a software space of the system, it was very important to us to ensure that the product was easy to use, easy to understand, and easy to access. Here to explain more about our IoT side of this product is Craig Clem, our IoT manager, also the guy that can help reset your password if you ever forget. So Craig, would you mind taking it away with our IT side of the product?
Thank you, Hannah. You're awesome. You know, it's great to be part of the Internet of Things technology and Flow-Rite's passion for battery health management. Hi, folks. This is Craig Clem. I'm Flow-Rite's IoT product manager. With the best-in-class battery sensors built into your tracker, we offer the best-in-class web console to monitor and manage your battery fleet. With this console, you can manage a fleet of battery vitals. What happens behind the scenes is the battery vitals are collected real time at the battery by the tracker. Battery health is then uploaded to your web console every time you synchronize with a smartphone. If you have installed a battery Steward gateway, your synchronization happens about 10 times an hour or every 6 minutes, ensuring fresh data for your critical battery operations. So whether you view your vitals on your mobile device or your web portal, you can use the web console to schedule maintenance tasks to help prevent battery degradation or failure. But to be sure you don't miss anything, we generate alerts when vitals exceed set limits or tasks when not completed for easy identification and correction. Let's go to the next slide. Here you'll see various charts displaying battery health. This is what we produce on the portals so you can see in a group what's going on. Things like temperature, and they help you navigate and assess whether your battery is operating well or needs maintenance. And like the chart on battery amp hours, access to easily readable battery health data can be viewed in the office while walking on a plant floor or at home in quarantine. Let's go to the next slide. Just to reiterate, we have made the system easy to install. We take out the stress of setting up your tracker and gateway. You simply attach the tracker to your battery, plug in the gateway to an outlet, and download the Battery Steward app on your favorite mobile device. In minutes, the battery health data begins uploading to your smartphone, laptop, and for your complete battery health management. So let's get back to Hannah.
Thanks, Craig, so much for explaining the IT side of our systems. You know, as a member of the sales team at Flow-Rite, it's really important to us to know that we have the support and help of such a great development and technical team when we're out in the field. So we asked to have Hank and Craig on this call, not to just explain the technical side of our products, but to also let everyone know who's listening that you have the complete support of our sales and customer service team, and also our development and technical team. If anybody wants Hank and Craig's direct contact information, I would be happy to share it with you. They love getting calls all day, every day. So isn't that right, guys? Now we're going to open up the presentation to our question and answer portion. If you haven't had a chance to submit your questions yet, please do so to the panel on the right of your screen. If you have submitted a question and we don't get to it in this time frame, don't worry, a member of our sales team will reach out to you later today. So Craig, it looks like the first question would be great for you to answer. How many gateways are needed in one facility?
You know, these questions are always, you know, it depends. And so I'll give you what it depends on. And it's pretty simple, actually. Generally, it depends on gateway placement. So you want to place them in the spaces where your vehicles are parked, like for charging or for watering, or where you take breaks. And honestly, even maybe a stop at the restroom, if you're parked there, we could probably capture and synchronize the data there. But typically, our gateways reach about 100 feet radially. So if you're thinking about how many vehicles you can place in a 100-foot or kind of a half circle area of 100 feet, that's the limit that we'd be able to capture with a gateway. Also, if you have very small vehicles and you can fit more than 40, in that space, we limit you to just the 40 devices per gateway. So if you have 60 or more, you'd probably be looking at 2 gateways.
Okay, thanks, Craig. The next question looks like a good one for Hank. Hank, how is impact measured?
Oh, well, we have an accelerometer in our tracker. So, and typically, you know, we ask that as you install the tracker that you tie wrap it securely to the top of the battery. And that way, whatever the battery feels, the tracker feels. And we're measuring it in G's, G loads. So what you'll probably end up doing with that is we have a default with our app. You'll run the default for a while. If let's say you got this fork, this fork truck, the sit-down fork that's coming in and out of vans, and you're getting a lot of alerts because it's exceeding the 3, I think it's 2.5 or 3G, which is the sort of the default. Then you as a customer might put in there whatever 5, 6, 7Gs to make sure you don't get false triggers for when these vehicles are going in and out of a van. So it's a customer usable, customer definable threshold, but it's based in Gs from an accelerometer that's mounted inside of our tracker.
Perfect, thanks, Hank.
Yep.
The next question I see, I'm gonna actually take this one myself. The question is, can you set the system up to text multiple people if watering is needed and has not been done for a certain period of time? Yes, you can. Anyone who is part of the Battery Steward organization has the ability to receive notifications of a task due or a task overdue. You just have to set up that set schedule of whatever you want that task to be, whether it's watering the battery, cleaning the battery, charging, anything like that. Our next question would be a good one for Craig. Craig, what type of information is required to set up an account?
It's pretty simple, actually, Hannah. It really is just you need to navigate to the batterysteward.com website, and I believe you've got that information later on in the presentation. And you know, with your cell phone or your tablet or your laptop, and in there's boxes of information that ask you about yourself, about where you work, about your batteries and your vehicles. And you can get everything set up there, and then also included in there is a way to start an organization which is really the company where you keep all your equipment, and filling in all that information get you started and get you rolling really quickly. Also, we have a mobile app for both the iOS, the Apple phones, and the Android phones, so you can download that as well from their respective stores and load all that same information from the mobile app. Does that answer your question, Hannah?
Yes, that is perfect. Thank you, Craig. I actually just got a text from one of our members of the sales team, Kyle McKee, and he wanted me to remind everyone that our advanced battery steward system will work on any industrial battery. So we don't need a specific type of battery or a specific type of charger in order to work our monitoring system. We'll work with all of them. And we also have them available in a variety of different in-valve level sensor options or a drill-in option. So then I think we have time for one more question. Craig, maybe you can answer this one. How is the gateway communicating to the cloud?
Good question. There's a couple ways. The gateway is really your key entry point to connect to the cloud. The gateway has 3 modes of communication. One is a wired connection, Ethernet connection. The other is a Wi-Fi or wireless Ethernet connection to some switch inside your facility. The third is a use of a USB cellular dongle, which allows you not to have to connect to anything in your facility and directly connect to the cloud in that method. So I guess that answers your question. Is there something specific that you had in mind?
That was our That was the question. We'll reach out to the individual that asked it separately and see if he needs any follow-up. So thank you for that. Actually, we had one more question come in. Hank, maybe you can help answer this one. What type of temperature are we tracking with the tracker?
So we're tracking, I guess I'd call it ambient temperature on top of the battery. We don't presently have a probe that goes inside the battery or between the cells. We opted for that for the easiest installation and integration. You can imagine though that any temperature, there'd be basically like a temperature buffer. It's almost like a capacitance, if you will, temperature capacitance between a device on top of the battery and what's going on inside the battery. But our temperature is to make sure that the battery is being utilized, right? That it's living and breathing and actively being drawn upon and charged. We want to make sure the customers recognize this as well. So if batteries are not being fully utilized, you're not seeing current coming and going, you're not seeing temperature excursions, you have to ask yourself, what is this vehicle, what is this battery actually doing? Is it left behind? Is it a vehicle that's not being utilized? There's a problem. Maybe it's a battery that someone's tossed in the back of the plant that is a troubled child that nobody knows about. Well, now you can go look for it, figure out what's going on. Information for you to utilize with respect to battery utilization.
Great. Thank you so much, Hank. Thank you, Hank and Craig. I think that's all the questions we have time for today. If you have a question that comes up, to everyone listening, if you didn't get a chance to ask your question or want some more detail on something, please feel free to reach out to any of us and let us know. If you did ask a question that was not answered today, we will definitely be reaching out to you later this afternoon. Just thank you everyone for joining us today. It was great having everyone on, and we're really grateful for the support that we had here on our webinar. Please, if you have a chance, follow us on any of our social media platforms that you may use. We'll post company updates and product updates on all of these. So love to have you follow us there. Thank you again. And that concludes our webinar for the day. We hope to see everybody soon. Have a great day, everyone.